Title of the first section is Domain and Range. Two definitions: domain. Domain is x values. And second definition, range. Range are the y values. So when looking at a graph or a list of numbers, the domain will be all the x values and the range will be all the y values. First problem is a t-table or xy chart. The x values are 1, 2, and 3, and the y values are 4, -5, and 7. Looking at the t-chart or the table, we can determine the domain and also the range. Domain is a list of the x values. X values in this case are 1, 2, 3, so the domain would be 1, 2, 3. And likewise the range, the y values are 4, -5, and 7, so the range would be 4, -5, and 7. Second question is a graph on the xy axis. We'll go out to 3 in each direction. The first point is at -1, -1. The second point is at -1, +2. And the third and final point is at 3, +1. So in this problem we have 3 points on a xy axis. From this graph we can determine the domain and also the range. The domain again is the x values. Looking at the first point that we had, the x value was -1. The second point we had, the x value was also -1. Since we have it listed once, we don't have to list -1 twice. And the last point, x value we had was 3. So the domain would be -1 and 3. Likewise the range, the first point, the y value was -1. The second point, y value was 2. And the third point, the y value was +1. So our final answers: domain is -1 and 3. The range is -1, 2, and 1. Third question and last question for the section. Again, is a xy axis graph. We'll go out to 2 in each direction. One point on the graph is at 0, -2. And this point will be the vertex of a parabola that opens up. The parabola curves up to the right and also curves up to the left. So this is a graph of a parabola that has a vertex at 0, -2. From this graph we can find the domain and also the range. The domain again is all the x values. Looking at this graph, the line consists of many or infinite points. All those points contain any x value on the graph. You can take any number on the graph negative. If you go up high enough, the graph will go up to that point and the x value will be on the graph. Same thing for any positive value. If you go up high enough, any positive value will also be on the graph. So since every x value, positive and negative, is on the graph, the domain will be all real numbers. All real numbers again, because every x value is on the graph. For the range, if we look at the y values, every positive y value is on the graph. Again, if the graph continues up high enough, any positive y value we can find on the graph. For negative y values, if you look for the lowest point would be the vertex on this parabola that curves around at the y value of -2. There are no numbers less than -2 that are on this graph. So the range has to be -2 or bigger, or the range y has to be greater than or equal to -2. So again, the domain, every x number is on the graph, so it's all real numbers. And the range, the smallest y value is -2, so all y values have to be greater than or equal to -2. Title of this section, is it a function, and is it discrete or continuous? The first definition is 1-to-1. 1-to-1 states only one x value for every y value. What that means is every x value can only have a single y value. If you have the same x value listed twice, but the same x value has different y values, then it is not 1-to-1. Second definition, vertical line test. Definition is passes only one point. If a graph is drawn, you can draw a vertical line through any part of the graph. A vertical line goes straight up and down. If it passes only one point, then it passes the vertical line test and it's a function. If it does not pass the vertical line test, which means it goes through 2 or more points, then it does not pass the vertical line test and it is not a function. The next definition, discrete. Discrete is a set of points. Looking at a table or a graph, if you can count up how many points there are, then it is discrete. Continuous, if you have a line or curve, there is an infinite number of points on every line and every curve. An infinite number of points means it's continuous. First problem for this section is a t-table or xy chart. The x values are 1, 2, and 3, and the y values are 4, 5, and 6. The two questions we'll answer: is it a function, and is it discrete or continuous? Looking at a table of values, we can use the 1-to-1 definition. 1-to-1 means every x has a single y. In this case, all the x's are different. Anytime you have all different x values, it is automatically a function. The second question, is it discrete or continuous? Looking at a table of values, there's 3 points, 1, 4, 2, 5, and 3, 6. There are 3 points in this graph, or a set of points, which will make it discrete. Anytime you can count up the number of points, it would be a discrete. Second question, another xy t-chart. The x values in this case are -1, 0, and -1. And the y values are 5, 10, and 15. When using the 1-to-1 definition, you want to look for x values that repeat. In this case, we have -1 that repeats. 1-to-1 means every x value has one y value. In this case, -1 has a y value of 5, and -1 also has a y value of 15. So if you have the same x value and they go to two different y values, that makes it not one-to-one or not a function. If it is not a function, it is neither discrete nor continuous, so the answer would just be not a function. Second question, or third question. Have another t-chart, xy table. Numbers for x are 5, 10, and 5. And the numbers for y are 1, 2, and 1. Again, when looking at a table of values or using the one-to-one definition, one x value has to have every one y value. The x value 5 repeats. 5 has a value of 1, and 5 also has a y value of 1. Having the same point means they go to the same y value, which is okay. It's still one-to-one and is still a function. So repeating x values, it's not okay to have the different y values, makes it not a function. But if repeating x values have the same y value, it's still a function. Looking at the t-chart or xy table, there's 3 points. If you can count up the number of points, it is always discrete. Fourth question is a graph on a xy axis. This graph starts at 0, 0, and is a parabola that opens up, curves up to the right, and curves up to the left. When you're looking at a graph, you can use the vertical line test. The vertical line test says you can draw any vertical line through the graph, and if it only passes one point every time, it is a function. So in this case, any vertical line you can draw passes one and only 1 point, so it is a function. When looking at a graph of a line, there is an infinite number of points on this line. An infinite number of points, or if you have a graph or a line or a curve, it is continuous. And last problem for the section, again, is a xy graph, and we'll have a circle around the center of the graph. The circle, again, has an infinite number of points around the circle or on the circle. And if we use the one-to-one graph, you can draw a vertical line on the outside, which doesn't pass any points, which is okay. You could draw a tangent line that touches 1 point on the outside of the circle, which is still okay for being a function. But if you draw a line anywhere inside the circle, the vertical line passes 2 points, which makes it not a function. And again, if a graph or t-table is not a function, it is neither continuous nor discrete.